Hello everyone, welcome back to this YouTube channel, IBwontcrushyou, and today we're dealing with Voronoi diagrams. Problem 1. 3 points called sides are located on the coordinate plane A, B, and C. A. Construct the Voronoi diagram for these three sides. So firstly, we will just draw dots as our points A, B, and C. So these are our points, and now we have to find the midpoint of each segment. So in order to find midpoint, we have to use our very simple formula, or maybe you already remember it. So midpoint is x1 plus x2 divided by 2, because we have two digits, x1 and x2, and the same as with y. So y1 plus y2 over 2. And we have to find it for every segment. So for AB, AC, and BC. So these are our midpoints, and now we have to plot them. So firstly, 2 zeros, so our first midpoint is in here, the second is 1, 2, so in here, and the third is 3, 2, so in here. Now we have to draw perpendicular bisectors. So basically they are just perpendicular, as its name suggests, just to our line segments. So something like this in here between A and B, and here between A and C, something like this, and here between B and C, something like this, and that's our Voronoi diagram. B. For the point P, 3, 2, determine to which Voronoi region it belongs. Justify your answer without measuring exact distances, but by comparing locations. So as you can observe, our point P with coordinates 3 and 2 is basically our midpoint BC. So it lies in here. So that's why our point P is equidistant to B and C. So this is the same distance from C to P and from B to P. And it's of course closer to B and C than to A. So we can say that P lies on the boundary between the Voronoi regions of B and C. So that's our answer. C. Explain why every point on the line segment joining A and B must belong either to the Voronoi region of A or B, but never to the region C. So in order to explain it, we can take 2 points, or maybe, maybe 2. So we will take, for example, this point and this point. So this point has coordinates 1, 0, and this 3, 0. And now we have to take the formula for the distance and calculate firstly the distance from, let's say this point is x and this point is y, so from x to A, and then from y to B, because in our command it is written that this point must belong either to the Voronoi region of A or B. So we can observe that x is closer to A, so we will calculate the distance AX, and y is closer to B than to A, so we will calculate the distance BY, and of course XC and YC. However, for now you can observe that distance AX and BY are smaller than the distance from x and y to c. However, we have to prove it. So, as you can observe, 1 is of course smaller than 4.12, and here we have the same situation, so 1 is smaller than 4.12. Problem 2. A farmer measures soil moisture at 3 sites, P, Q, and R. A. Construct the Voronoi diagram for these sites. So, as in previous problem, all we need to do is just to plot them on the graph. So these are our points on the graph, and now we have to find midpoints. So our Voronoi more or less looks like this. And B, using nearest neighbor interpolation, estimate the soil moisture at the point M for 2. So firstly, let's plot it. So in here, M for 2. And nearest neighbor interpolation means that the point, so in our case M, is in the side that contains also Q. And we're given soil moisture for Q, and this is 20%. And nearest neighbor interpolation means that the point that falls into this side, let's say, has the same features that this point Q. So basically our soil moisture at the point M is 20%. And point C, explain one limitation of using nearest neighbor interpolation in real world contexts. So you can think of any, let's say, problem in your real life that can use this nearest neighbor interpolation. And we can say that nearest neighbor interpolation is discontinuous. That means that the predicted value jumps abruptly at Voronoi boundaries, and it ignores gradual spatial trends and basically can produce blocky maps. And this can be our answer. Problem 3. 3 phone towers are placed at T1, T2, and T3. A. Construct the Voronoi diagram to represent coverage regions of each tower. So, as in previous problems, firstly we have to plot these phone towers. So these are our points plotted, and now we have to calculate midpoints. So our graph more or less looks like this. B. A new tower is planned at T4, 5, 4. Predict without detailed calculation which existing tower's coverage will shrink the most and justify. So let's firstly plot our point. So in here, T4 with coordinates 5 and 4. And you can observe that our T4 is in the cell containing also T3. And T4 sits directly beneath T3. So the points that were previously closest to T3 in the middle band will now be closer to T4, so T3 will lose the largest share of its region. And of course T1 and T2 will also lose small triangular pieces near the center, but the biggest impact is on T3 because as you can observe, T4 is placed closest to it. So these are our calculations, and as we expected, T4 is the closest. Problem 4. 4 sites are located at A, B, C, and D. A. Construct the Voronoi diagram for these sites. So as in previous problems, we have to construct the Voronoi diagram. So just firstly plot these points, then find midpoints, and then draw perpendicular bisectors. However, here we are given 4 points. So let's plot them and see how our Voronoi will look like. So this is our Voronoi diagram. We calculated the midpoints, and our points A, B, C, and D, they basically form a square. So our Voronoi, these perpendicular bisectors, they basically look like a cross, so something like this. B, the largest empty circle, is the circle inside the convex hull of the sides that does not contain any side and has maximum possible radius. Locate the center of this largest empty circle and then determine its radius. So firstly, locate the center of this largest empty circle. So here is a simple situation because our center will be in here. So 4, 4, because we have a square from our points, our center will be 4 and 4, and determine its radius. So now we have to draw the largest possible empty circle. So the circle with center 4, 4, and the circle that doesn't contain A, B, C, and D. So as you can observe, our circle doesn't contain any side, and we can observe that the radius is basically 4. And C, interpret what the circle represents if the sides were restaurants in a city. So if our sides were restaurants, the largest empty circle shows the largest area within the city that is farthest from any restaurant but still inside city boundaries, and its center indicates the best location for placing a new restaurant to cover the largest currently underserved area. And that was the last problem from this topic, Voronoi diagrams from the chapter Geometry and Trigonometry. And if you found this video helpful and useful, please leave thumbs up, subscribe to my channel, and in case of any questions or any doubts, feel free to reach me out in the comments down below or via my mail that is as always in the description of each video. And in the description you can find the information about a little contest.